Welcome to Science in the Hands of Scientists. I'm Carl Zimmer, and this afternoon we're going to have a conversation about how science happens. You know, we have to bear in mind science is not something that happens in the abstract. People do science. And so these are not, gods who are impervious to the forces that shape us. They're human like the rest of us. And they deal with all sorts of factors that everybody else does. It can be everything from pressures to get a job, to get funding. There can be internal biases. There can be the thirst for glory. There are all sorts of things that can shape how scientists decide to do science and what they choose to do. And that's what we're going to be talking about this afternoon. We're going to have an open discussion about the scientific process and how it works from the classroom to the lab, to the journal, and then out into the rest of the world. So let me start now to introduce our panelists. Our first guest this afternoon, she is a principal investigator at the Tufts Center for Regenerative and Developmental Biology. Please welcome Dani Spencer Adams. Our next guest is the K.D. Irani Professor of Philosophy at City College of New York. He works on the philosophy of science and the nature of pseudoscience. Please welcome Massimo Pigliucci. Our third guest today is a distinguished writer in residence at New York University's Arthur Carter Journalism Institute. He's the co-founder of Retraction Watch. Full disclosure, I have written about his work for the New York Times. So please welcome Ivan Oransky. And last but certainly not least, our final guest is the editor-in-chief of Scientific American. She also oversees the journalists both at Scientific American and at the Nature journals. Please welcome Marietta Cristina. So now that I have you all out, let's just start by just kind of talking about how you make a scientist. And maybe, Dani, I could start with you. I mean, so you have a lab and you are bringing in students at Tufts who want to be scientists. So how do you take them from being students to people who are going to do science in the 21st century?
I would describe it mostly as like an internship, or you. Most of it is just being thrown right in. Here, do this, and there's a lot of supervising, teaching specific things, specific skills, specific techniques, protocols, and then there's the other. It's more of a meta kind of approach where you have to teach really. You could call it scientific thinking, you could call it scientific method, but really the idea that science is simply one way of learning things. And it's been a very, very powerful, very good way of learning things. And it's in some ways not human-like. I don't want to say inhuman, I don't want to say superhuman, but humans, and I'm very much looking forward to the rest of my panelists talk about this, but humans have what's called confirmation bias. And we tend to recognize and remember the things that confirm what we already believe. And I just throw this out, most people, if you think about the newspapers you read, you're not, most of us, me included, I'm not looking for new information. I'm looking for confirmation for what I already believe. And
so you can say, I knew it.
I knew it. Yeah, I knew that was, he shouldn't have been elected. No names. And I think that one really useful way to think about science as a way of learning is it's about overcoming confirmation bias. So it's about phrasing a question in a way that allows you to ignore what you believe, or even say, okay, here's my idea, now I'm going to try and prove myself wrong. And I can't think of any other way of learning or thinking where that's what you do, where you say, here's my terrific idea, and now I'm going to try and kill it. And so learning the intellectual skills of thinking that way and asking questions that way, and controls are all about proving that what you thought was going to happen wouldn't happen, that it was actually the injection you did, or it was actually because the air conditioner was on, or it was Thursday. And I think that is what makes it so powerful, is that it's about overcoming confirmation bias so that you can see what's there rather than what you were expecting.
Do you find that you have to to push them further when they're sort of satisfied that
Absolutely.
they've done enough to try to prove themselves wrong? Like, no, looks like I'm right.
Yeah, absolutely. There's it's crushing. It's ego crushing. You come in and you're so excited, and you're going to get to have wonderful conversations, and there's fantastic questions, and you're going to find the answers, and you're going to change the world. And first of all, it's not like that. It takes a very long time. But you have to constantly say, all right, how would you disprove that? How would you disprove that? What's the proper control? How do you know that, how are you going to interpret it if you get one of these three possible results? And what are you going to do if you get something that you didn't predict at all? You have to teach that, and the only way to teach that we know of at this point is simply to do it. So students come in, and you get them started, and then you say, okay, no, that's wrong, and that's wrong, and that's wrong, and that's wrong, and there's a saying: if you're not failing most of the time, you're not working hard enough, and that's a hard thing to get students through.
Absolutely, yeah, and Massimo, you have a long career not only as a philosopher but as a scientist, and have trained your own.
Graduate students, yeah. So I was in evolutionary biology. I tend to agree with most of what you just said. I would even go even further in terms of, I'm a little more pessimistic about how the whole thing works. So ideally, actually, I think that a lab works a lot like a Renaissance, place where you go and learn from Michelangelo or from Leonardo or whatever it is, right? So a workshop. You come in and you learn because you are in constant contact and interaction with not only the master, that will be the PI, the principal investigator of the lab, but in fact also the people that have been there for a long time, so senior graduate students or postdocs or things like that, right? So you are immersed in an intellectual environment, and you're doing things every day, and that's how you learn how to do science. But I honestly don't think actually that individually we can, as much as it's a good idea to be aware of it and try, I don't think we can individually overcome a confirmation bias. The way it happens most of the time is precisely because the rest of the people in the lab, particularly the principal investigator, tell you, no, that's not going to work. Yeah. Why don't you think about it that way? And of course, who does that for the PI? I mean, who watches the watchman? That's the peer review outside of the lab, right? So you have the PI himself or herself has to get grant proposals approved. Those have to go through a process of peer review. Even if they are approved and the research gets done, then you have to publish the results. And yes, it is ego crushing. I mean, it's rejection over and over and over, and you just have to grow a thick skin and deal with it. But that's the way you learn it, by doing it.
So when you look at the cohort of new scientists, coming out, freshly minted PhDs in 2017. What's it like for them starting out now in science as opposed to 1997, 1987? Is it the same? Is it different?
In some respects, it's the same. The excitement is still there, and it's a great time for science, for biology, for physics, for other disciplines. But at the same time, you're also very conscious these days that making a career in academia it's not easy. The number of people. I mean, typically when we advertise for one position, there is like 150 applicants easily, and I guarantee you, a lot of them are actually qualified for that position. So it gets, that you get into a period of possibly several years where you go from one postdoc to the other or from one adjunct position to the other. And if you're lucky, you're actually going to make it by the time you're in the mid-30s or something into a beginning of a tenure track. So things are changing in that sense. The job market in the sciences has getting has gotten worse over decades. I mean, the real peak period that was in the 1960s and early 70s, where you could just go out and get a job.
Yeah.
It hasn't been like that for a while, and it's increasingly less so. But we also have a lot of talent. We have a lot of people that have, you do it because you have, you're excited about it. You really have the, want to experience the joy of being a scientist in the lab. You don't do it for the money because it doesn't really pay that well, and you don't do it for the benefits because those come very late in your career. You have to sacrifice a number of things. You do it because you love it.
So Ivan, Mariette, I mean, you're kind of more on sort of the outside looking in on this culture of science, and I'm curious if you see differences now in what it's like for scientists to be starting out and launching their careers in science now, as opposed to like when you started being journalists. I don't know which one of you wants to jump in.
I can start, and then Mariette will probably say something smarter and more scientific than I will. How's that? I was just struck, if I may, for 10 seconds, and just say what Danny was saying about, and I think about confirmation bias a lot. Everything that you said about scientists and how you really, ideally, want to wake up every morning going, how can I prove myself wrong? Well, journalists are supposed to do that too. And I'm not going to claim that I do that. I wake up usually and check Facebook. But you want to wake up and you need an editor. You need someone who's saying, well, wait a second. Yeah, you have that document, but that document doesn't really say what you think. So I just wanted to reflect on that for a second. I think that there are two. I wouldn't call them changes necessarily, but they've sort of accelerated, and I'd be interested to hear what others think about this. But there are sort of two phenomena that I think have accelerated. One is what I would refer to as a sort of metricization, right? So everything is now measured, and this is true in all walks of life. It's a sort of, if you'll forgive me, a little bit of not philosophy exactly, but political science, sort of a neoliberal idea that we can measure everything, and so that includes measuring impact of research. It includes something called the impact factor, which is a measurement.
So describe how you measure the impact of somebody's study.
So
how do you know?
Often, what a lot of it is based on, and I'm not sort of here to defend this, but just to say that this is what happens, is how often are other scientists citing that work? So if a tree falls in the forest and no one hears it, did it really fall? If a paper is published and no one cites it, does it really matter? And again, I'm not condoning that, but that is what matters. And so you turn that into a number. You turn into a number of numbers, actually, an ever-growing sort of forest of numbers, where you actually have something called impact factor. So the number of times on average, I'm simplifying here, that a given articles in a given journal are published. And a lot of people, and I kind of am in this camp a bit, say that this has really had a dramatic effect on science, and not necessarily in a good way, because everyone is pushed to publish in these high impact factor journals. And so they publish a lot of really good science, but it also, what it means is that tenure committees, promotions, anyone who sort of helps you to get ahead or is what you need to get through to get ahead, peer review committees, Massimo was talking about peer review, they all are looking for these numbers. They're not necessarily reading the entire paper anymore, which is what you would hope they would do. But they're just looking at, well, is it in this journal or that journal or what have you. And the other thing very quickly that I think is happening that alongside this and really feeding into it as well is that there was a blip, and now it's sort of looking more and more like a blip. From 1998 to 2003, if you look at the doubling, so the NIH budget, and that's not the only budget, National Institutes of Health, excuse me.
Main funder of biomedical research in the U.S.
Exactly. And this was a good thing for science. It meant that there was more funding, obviously twice as much funding over that period of time. But that stopped, and so, in fact, you could argue, and if you look at inflation, the amount of funding, federal funding from the NIH has declined. And yet, all of those graduate students, postdoc trainees, well, they were all working somewhere because labs just staffed up. It was like some kind of boom. It really was a boom. Well, for the past, whatever it is, 14 years now, we've gotten many, even more than we had, and it wasn't so good, as Massimo pointed out, since, whether it's the 60s or, early 70s. And so you had more and more people competing, all needing to get all these numbers, and lo and behold, we're seeing a lot more competition, and that a little bit of competition is a really good thing. Too much competition can really harm you.
Mariette?
So I'd like to thanks very much. And by the way, been fascinating just to listen so far. I don't know how it is for all of you there, but for me, absolutely wonderful. So I have two things I would like to add, just reflecting on the ideas of confirmation bias, on increasing competition, on impact factor, on the two areas. So first of all, I think a thing that we often don't recognize is the publishing's role in this ecosystem, and both at the popular level, so the Scientific American level, where I'm editor-in-chief, one way we can either foster haste in publication or not is how do we jump on this week salt is bad for you, this week it's good for you, can we take the longer view, provide context, not be slaves to the embargo system, the system where we all agree that a paper is going to come out a period of time from now, and then journalists like me and like Ivan, we get a few days head notice the idea is that we will all publish our stories at the same time, and we'll have had some equal access to the experts to do that without haste, but also comes with a whole host of other challenges, which we may or may not come on to later. So that's one aspect. So mass publications like Scientific American, and then the journals themselves. How do we? I am not a journal editor, although I work at a large publishing company, Springer Nature, which publishes 2,000 around journals and Nature,
including some of the biggest ones like Nature,
including some of the ones with the very high impact factor, very selective journals like Nature and the Nature branded titles. And how do we set standards there that in effect slow down that haste to publish, that enable a little more checking and accuracy, like reproducibility checklists, like checking methods and protocols, like supporting the research community, so those pressures that people like Massimo are calling upon or noticing are somewhat supported and slowed down a little bit.
Right.
And then I want to set the lens a tiny bit more broadly outside of publishing. So how do we as a society look at science and treat it? Do we, jump for the latest headline, or do we start with our kids when they're very, very small? Because researchers like Alison Gopnik will point out we're all born researchers, and you don't have to believe me. Just watch any kid on a high chair dropping different things off to see how they fall and they bounce or whatever. So we're all born experimenting. But over time in schools, we're taught through a series of classes that science is a set of received wisdom, and not something that you try and fail. Because, I'm watching my own girls, one now in college, one in high school, every experiment they take in every science class has a right answer. So this is kind of how the math society is left. So I encourage us to look at those two lenses. One is the role of publishing in the ecosystem and the broader role of society at large.
I have to say, as a journalist, when I was starting out, there came a point, and it took a little while for me to actually appreciate how much of the work of a scientist was filling out paperwork to get the money to do science. And I just sort of thought, well, somehow the money just sort of shows up in a box or something, and then the scientist does the science. I mean, when you read you read a biography of Einstein, you don't read him filling out an application in the National Science Foundation. You want to know how he came up with E equals MC squared. But I just remember, I think there was the one time it really hit me. I went to interview a scientist, a biologist, a leading evolutionary biologist. And I come into his office, and he's like, hold on, I can't talk with you just yet. And he was on a conference call with these co-authors who all wanted to get this grant, and they were trying to figure out why it was that the essay they wrote to get this money didn't fit on one page. There was something wrong with the font. And they couldn't figure out what was wrong with the font, because they had 2 or 3 words sort of spilling off the end of this PDF. And they're like, oh, why, and if we don't get this all on one page, there's no chance we're going to get this money. There's no chance we're going to be making this great insight. I'm just looking at them I didn't come here for this, And I had to wait 20 minutes for them to fix the friggin' font and apply for the grant, and then we could get to the science. And I'm just sort of wondering, I mean, that's the sort of stuff we tend not to report on, but it must obviously really, I mean, that must be a big part of what goes on in terms of your time, and then also how does it affect what you're going to decide to study?
Yeah, it's a very frustrating part of it, and it's something that I do wish more people knew about, because, I mean, your tax dollars put me through school. You trained me, and I'm trained to be in the lab and how to ask a question, how to design an experiment, and I probably spend 50% of my time writing the same thing over and over again, changing the font, changing the format, making sure this thing is filled out and that's filled in, and you know, we have a rule: never ever update your software within 1 week of the due date, because you will get messed up. Don't send from a Mac to a PC because it'll come back wrong. And it's very frustrating to do that. And the bigger the lab, so the more productive the lab should be, and can be and is, the more time the PI is probably spent. PI stands for principal investigator, and that's the big scientist in the lab. That's the person who gets all the credit, even though the work is done by many people. 60 to 70% of their time is spent doing the paperwork, writing the story. And on top of that, so the community, and I think the journalistic community as well, is aware of these issues and is trying things. Are there ways that we can get around this? And for example, the journal Development, which is the big journal in my field, has recently announced that you can submit it in any form you want. Mm-hmm. And they will deal with it. They've decided that reviewers are capable of reading a paper even if it's a different font than the one. So that's great. That's a really nice thing. Other journals are working. There are some journals now that are connected up so that if you don't get into the highest impact one, you can have it submitted to the next one down without doing anything else.
So
you can just
saving you time
so it's people
that you could spend on science.
Exactly. So trying to mitigate some of this silliness that we spend our time on.
But even when you spend all this time, I mean, if you look at the percentage of applications that are accepted and lead to a grant, yeah, right.
Yeah, I mean, that's the other problem is limited. There are limited funds, and the competition is intense.
How does that affect the science that you decide to do?
So the big granting agency, the National Institutes of Health, of which there's 18, I think, and by the way, the more important problem, I think, is National Science Foundation. So NIH is biomedical. NSF is everything else, and its budget is very small compared to NIH's. So right now, I think in my field, the places where I apply for money, you have to be in the top 4 or 5% of, your peers, people who will understand what you're trying to do, rank it, and then they decide, and you have to be in the top 4%. And if you're not, you will lose, that's it. There goes your salary. And that's hard. You're competing with people across the entire nation. And to stay in the top 4%, it's one thing to be an A student in high school. It's quite another to be the only A, the one A in thousands. And so what you tend to do is these agencies, what they do is they put out these things called RFAs, requests for applications. And these are where they're saying, all right, Congress has decided that what we should spend our money on this year is mapping the brain. And so they'll set aside, okay, we're going to set aside $50 million for people who want to map the brain. And then they put out one of these RFAs. And you go to the website and you think, well, okay, I'm a brain person. I'm going to go and I'm going to find out, is there money out there for doing this thing? Well, it turns out there isn't. It turns out that some congressperson got put in there that what really matters is this part of the brain. If you're studying the cerebellum, you've got a much better chance. But if you're studying the cortex, we're just not interested this year. So yeah, you might very well switch. And so it ends up ultimately being guided by Congress. It's up to Congress to say, this is what's on the agenda now. This is what we think is important. And the scientists are becoming more savvy about this. And there's a lot more scientists now going to Washington. And we now get trained in how to lobby for science. Because it loops back around to what you're going to be able, what passion, are you going to be able to follow your passion in the direction that you as the trained person think is the best direction to go, or are you going to have to fit it into something that came down from Congress?
how do you think about how this fierce competition then affects the papers that get published and then get reported on? I mean, do you see that? Do you see an influence happening there?
Yeah, I mean, there's a couple of things that I'd like to add to what you guys have been talking about for the last few minutes. So at NSF, in my field, evolutionary biology, the funding rate is 5 to 6%. That means that when I was an active PI, I had to write a grant proposal every semester. Oh. And 2 out of 3 would probably be rejected, which still was much higher than.
That's a fabulous record.
That's a fabulous record.
That's really good.
But that was frustrating. That was a lot of time. Then yes, you're right. You learn also how to lobby. That's another chunk of time that goes away from the science, and you do something that you were not really set up to do to begin with. But we have to realize that there's a couple of things going on. First of all, this is actually relatively new, and also it's not unavoidable because there are other ways of doing things. So it's new in the sense that NSF and all the major federal agencies were created after World War II. And that's why Einstein didn't have to do that sort of stuff, or Bohr didn't have to do that sort of stuff, because they were simply not around. Even after they were created, initially there was actually a flood of money after the war. It was we were in terms of economic expansion. There was science, especially physics, had a lot of cachet, and so they were just getting money. Period. As you said, when you introduced me, I'm the K.D. Irani Professor of Philosophy at City College. Well, K.D. Irani was hired, like 4 decades ago at City College because Einstein met him at Princeton, and he wrote to City College and said, "I like this guy. You should hire him." And he was hired. That I guarantee you, that's not going to happen today. It's just not going to happen. Turned out to be a good decision, but nonetheless. So all of these is actually fairly new, and it's gotten much, much worse over the last sort of 20 to 30 years or so. But there's also some very bizarre ways that are actually typical of the American system you don't necessarily find in other countries in the world, even in other Western countries. So NSF, for instance, for a long time has concentrated more and more money on a smaller and smaller number of laboratories. They go for the big projects. They go for the big things. One of the reasons is, as you were saying a minute ago, because that sells to Congress. And I can tell you a story that occurred a few years ago that I thought was hilarious and at the same time extremely sad. So I was invited to a NSF retreat with a bunch of other ecologists and evolutionary biologists. And they told us, look, we want to give you big money. But the way to give you big money is to attach it to some kind of big project, because otherwise Congress is not going to do it. And so they said, try to tell us, think about it for this entire weekend. Think about the equivalent in ecology of, let's say, an astronomical observatory or a satellite or something like that, or a particle accelerator. So let's say that we want to give you not the usual $500,000, $600,000, but $30 million. What would you do with that? And it was hilarious because the answer was, I could hire 200 postdocs because most of the work in ecology is field work. I don't need an observatory or a satellite. I do need, however, a lot of people in the field, doing the actual work. But that isn't the kind of thing that is selling a project to Congress. Other countries do it differently, although unfortunately, more and more they're following the American model, because America is capable of exporting a lot of good things and then a lot of bad things, and the rest of the world somehow buys it. So Canada and most Europe, for instance, they do a different system where they give smaller grants to a much larger number of labs. And the way it works is you write much smaller proposals. Instead of a 15-page proposal for NSF, you have a 3 or 4 pages proposal. And all you have to do is really to maintain a certain publication record. If you can show that over the last 3 years you have published a decent number of papers in decent journals, and then you now have a new idea, you want to proceed in that direction, they're going to look at it and say, yeah, sure, good enough. We're going to give you the money, and we'll see how it goes 3 years down the road. That's not the case for NSF, NIH, and things like that. So there are different ways of structuring the system, and I think that part of the problem is that, of course, the American system is the one that does pump more money than anybody else in scientific research, and so we think of science in the way in which it's done in the United States, but it's not the only model.
Yeah. So what's your perspective on?
Yeah, I mean, it maybe pumps more money than many others, but the sad fact about U.S. research is the funding overall has been roughly static since the 1980s and down.
Yeah.
And I actually get quite concerned. I like science that provides solutions as much as the next person, because, one of the challenges and why Nobel Prizes take so long is basic research may take decades. to then get to applied. And surely Einstein, who was mentioned earlier today, and this is something that maybe a lot of folks in the audience have heard already, certainly when he was working on relativity theories, it was never thinking about it being applied in my iPhone with my GPS, which of course we do every day without thinking. But even the iPhones have a couple of dozen innovations in them themselves that nobody thought of would be applied later on. So it's one challenge I see. Some interesting models I also like are places where in Europe, I think there's some great leadership on this, funding the researcher rather than the research projects, which I think is really encouraging.
How would that work?
So a researcher has demonstrated through some initial work over time that they have some interesting lines of inquiry that they will be pursuing, and they get a block of money for maybe 5 years at a time instead of one study, the next study, the next study. I think that's quite interesting. I think that's one way to look at it. Another is for the publication piece of it. You might decide that the publication will be okay as long as the methods and statistical accuracy that you're going to use for analyses are agreed beforehand. And one of our relatively newer journals, Nature Human Behavior, is looking at this sort of model as well, so that the researchers know when they've submitted something, they get kind of a pre-peer review almost, that tells them that when they get done through it, they will get to publish something. So models like that. And also, I'm thinking broad, MIT and Harvard, and how they have staff scientists to help work and remove some of that admin burden that many of the researchers are shouldering. You mentioned about grants and listening to people as they're fussing through the grants. I think the long story short of it is that there are so many elements that challenge research, and we're going to have to take a kind of a multi-pronged approach to solving all of these various problems.
I want to switch gears a little bit, and Ivan, maybe you could tell us a little bit about Retraction Watch, because I want to sort of talk about some of the things that, with the panel as a whole, about some of the things that you kind of expose as you run this site. So why, as a journalist, why would you say, hey, you know what I'm going to do? I'm going to set up a website dedicated only to retractions of scientific studies? Like, why would you do that?
That's a great question, Carl. If I had the answer, I probably wouldn't have started it. So Adam Marcus is my co-founder. He and I launched Retraction Watch not quite 7 years ago now. It'll be 7 years in August. And to be honest, the basic idea, there were really two guiding principles or sort of reasons why we were interested in doing this. In particular, Adam had been reporting on retractions for a while. I had been doing the same, but credit where credit's due. He had broken a couple big stories. One particular anesthesiology researcher who ended up going to prison because of scientific fraud. It was a very rare phenomenon, a very rare event. But that, of course, grabbed everyone's attention. In fact, I was at Scientific American at the time, and we reported on this after Adam did and all that. And so and that sort of speaks to the fact that often scientific retractions, maybe I'll just back up and explain what they are.
Sure.
Because I think that to many people, including me until about 7 years ago, it wasn't quite clear. This is sort of, if you will, and I'm going to mix metaphors, and I should definitely not do this with Massimo here, but this is the sort of nuclear option, if you will, of self-correction or of any kind of correction in science. So you're saying not only was there a problem with this paper, this finding, maybe there was an error here, but you shouldn't trust it. You shouldn't rely on it at all. You shouldn't cite it, or if you do cite it, you should make it very clear that it's been retracted. It is, again, retracted from the literature, withdrawn from the literature. Guidelines say it should still sit there in the literature, but be marked really almost with a scarlet letter. In fact, often a red stamp that says retracted on it. And so that's what a retraction is, and what Adam started seeing with these retractions from this particular anesthesiologist was, wow, there's a great big story here. And as a journalist, I mean, there are investigative journalists who I admire and just want to be one day, but really, Adam and I think of ourselves as finding stories that are hiding in plain sight. And retractions are a great example of that. So here's a bunch of retractions. They seem very arcane. Why is this paper being retracted? And oh, wait a second, this guy's made up all the data for 25 different studies. So there's that line at the end of a lot of Hollywood movies, no animals were harmed in the making of this film. And so it was sort of like that. No patients were harmed in the making of this study because there weren't actually any patients in this study. So that's sort of a different take. So there was that element. But the other thing we noticed was that the retraction notices themselves. This is not a very transparent process. I mean, the process is not transparent. The outcome is not transparent. So the retraction notices themselves were either, some of them actually told you what happened, but a lot of them, either they were sort of mealy-mouthed, they wouldn't really tell you this whole story, or they would actually be wrong. They would make something sound like it was an honest error when in fact it was fraudulent. And it turns out, we've now learned, a few years after we started the blog, that the number of retractions has dramatically increased. It's far outpaced the amount of papers being published. In other words, the rate of growth in that. And I think, in fact, when you and I, one of the times we talked for the Times, was about a study that came out showing that. The number of retractions went up tenfold from about 40 per year in 2000 to 400 per year in 2010, and it's continued to grow. That's out of about 1.5 to 2 million papers, so it's still a very rare event. And the other thing that's happened is that we know that now 2/3 of them are due to misconduct or due to fraud. So there's the sort of U.S. federal definition of fraud, and it is, or misconduct, signs of misconduct, which is something that has also been sort of exported to other countries, and there's a lot of agreement on that. But it's FFP is the what do you call it? Sort of acronym. So it's falsification, fabrication, and plagiarism. Plagiarism hopefully is self-evident to everyone in the room, but we can talk later if it isn't. But falsification is you did an experiment, but it didn't go exactly the way you think it should have gone to prove the sort of whatever it is that you're trying to prove. So you fudge the results a little bit. Maybe you literally used Photoshop and you take out the little band that shouldn't have been there in a little spot, and I'm sure that was just an error. The lab tech didn't have enough coffee that morning, and so I'll just erase that one. That was an outlier.
The ultimate in confirmation bias.
That's complete confirmation bias.
I
And
know
then
I'm
there's-
right,
Yes.
so I'll just tweak the photograph just to
Right.
everyone knows.
Yeah.
And then the other F is fabrication, where you actually make it up, like this guy Scott Rubin did. And so that's the sort of triad. We've seen a lot of other things happening, crazy stories about people doing their own peer review, actually managing to peer review their own papers. I mean, I'm sure you all are familiar with peer review. The idea is that it's been done by a peer. Now, I happen to think that I'm peerless, of course, so there are no peers. But you actually are supposed to have someone else do that. It turns
It's not
out
a reflective property.
it's not exactly. So there have been just about 500 papers retracted because people figured out a way to either peer review the paper themselves or have someone sort of do it for them so that they could then peer review their paper. And not in the sort of usual way that we all know that happens, but a directed way. So.
Mary, what's your feeling on sort of, the issue with retracted papers and, perhaps as reflecting these pressures we're talking about?
Yeah, no, it's certainly, acknowledging all the pressures, and actually, I just want to put in a praise for Retraction Watch and for scientists who, let's not forget, science is a process. I talked a little earlier about how we sometimes in school, in early school years, treat it as a series of received wisdom, bits of facts that everybody knows, and that's always true. But actually, one of the things that's very wonderful about science is that it tries to embrace its corrections and self-corrections and so on. And I also thought, listening to your excellent outline, Ivan, that a thing we should mention for folks who may be not familiar is that, the fact that you can reproduce something doesn't make it right, and the fact that you can't reproduce it doesn't make it wrong. There are lots of things that happen in between. Problems with your reagents, problems with the techniques, with the methods used in the lab. And this is why, I talked a little earlier about what publishing outlets like mine can help do. For one thing, in our journals, they removed the restrictions they used to have on length of methods. You were talking about fitting a couple of words on a page. We used to have restrictions, and now online they can be much longer and provide more detail, so other researchers can help provide that course correction by checking something, or providing protocols, or providing the raw data, which we now increasingly hook to the figures that are in the papers as well. All of these help the scientific communities police themselves, in addition to, you're quite right. Of course, there is wrongdoing. I mean, science is ultimately done by humans.
Sure.
We're all flawed every so often, but there are these larger factors at play as well.
Right, but even if people are not committing fraud or misconduct or fabrication, I mean, there's also the issue of have your students challenged themselves enough, or have they said like, well, I got the value I want, I got to go publish,
That's
rather
right.
than take.
P-hacking.
Yeah, it's known as p-hacking, right, exactly. And so I mean, do you see that as a pressure? Like, maybe young scientists don't have the luxury of spending another year or two saying, like, I don't think that's quite right. Let me make sure that my results are good.
A couple of comments to some things I've heard here. One is that another one of the perhaps unique things about science is you don't have to be right.
How do you mean?
So, science meanders. I love the title of this salon. An adjunct to that point is that the way scientific studies are reported, the structure of a scientific paper, an introduction, a section that describes how you did it, a section that describes what you got, and then there's a whole section called the discussion where you put in what you think it means, and you may be wrong, and that's fine. That's not the criterion. The criterion is, did you do the right thing? Did you do the right controls? Did you use your techniques properly? And the results, this was described to me when I was a student as the results is the part of the paper that will never change. When you did exactly what you have said, and the methods and materials section is supposed to be where you provide enough detail that someone can replicate it. And then there's the results. That's what happened in that situation on those days with those reagents and da-da-da. And it's one of the things I think that makes these papers very boring because, what's the fun part? The fun part is, well, what does it mean? What does it tell me? How do I interpret this? But it's absolutely critical. And I'm not the person who's going to figure out how to do this, but that's the stuff that gets lost when you switch to journalism, where you need to have a headline, where you need to sell a paper, and you have exactly 2 inches for your headline, and it's. But the point I wanted to make is that this is the structure of the paper, that convention, that tradition, is another one of the ways that scientists police. Is it going to come out right? You say, here's what I did, and it's open game. Anybody who wants to, and who has the money and the equipment, can replicate it and disagree with you. And you have this whole section that's your opinion, and it's separated out, and it says, this is the editorial part. Here's what happened. Here's the editorial part. And we build on each other. We don't have one person who's studied, we have Newton, and we have these wonderful laws, and that's great, and he was wrong. And he was wrong when you try to then apply them in other circumstances. But science meanders and science builds, and of course you end up with, you want your grant, you want your headline, you want those things, but there are so many little places built in to try to keep us honest.
But
Right.
to some extent, isn't there a question of incentives? And the incentives can be structured, again, differently.
Yeah.
Right? So, for instance, we talk a lot about replication, but of course there is no incentive whatsoever to replicate somebody else's results. You don't get on a belt.
So explain, why wouldn't scientists want to spend their time trying to replicate what someone else did?
Because it's only the adventure, right? You want to be the first one to get there, not the second one or the third one or the fourth one.
And you can't publish it.
And
Usually
you don't publish it.
Well, why can't you publish it? I mean,
because most journals, especially the high-impact journals, want the novel stuff, the sexy stuff, the things that nobody's done before, right? So even though that's slowly beginning to change, there are some journals that do accept replications, but those are not the ones that you build your career on. You don't become famous as a scientist by saying, I checked these other guys' work, and it turned out to be correct, right? Nobody, it just doesn't pay to arrive as number 2 or 3 or 4. So that's one thing. In terms of incentive structure, there's also the issue that the publish or perish sort of culture arguably has always been there, at least since World War II. But it has gotten worse, precisely because there is a large number of scientists, a large number of journals. How many journals did you guys publish?
Springer Nature is about 2,000.
so
2,000
you alone,
That's just one
Springer
publisher.
Nature publishes 2,000 journals.
Right.
That's one publishing
one
house.
publisher.
Right. So the result of it is that, you were saying earlier, if somebody publishes a paper and nobody reads it or cites it, that, what was it? Well, the thing that really opened my eyes is a few years ago, there was a study that showed that of all the papers published in major top biology journals, the really top-notch journals, 1/3 only is cited within 5 years from publication. That means 2/3. Let's get this straight, right? 2/3 of top papers, papers published in top journals, never get cited. Period. That's a lot of waste of money and energy.
Well, I mean, the
and
question, though, is, I'm sorry to interrupt you, but it should citation, obviously, there are many alternative metrics as well.
Absolutely.
Citation is important.
Absolutely.
Publishers also do have places increasingly now for publishing negative results, like
Yeah.
scientific reports, and my own
Right.
journal group will allow
No,
that
you're
kind
right.
of publication to help support
You're right.
science over time.
so it's about the,
Yeah, so
the
incentives
thing
is a great point.
Yeah, so you can change the structure of the incentives. So one of the things that some people, including my colleagues, and I've been doing when we get these 150 applications, for instance, from young people, postdocs, graduate students that want a new job, instead of doing the bean counting and say, okay, so how many papers you have, we say, okay, well that's nice. You published 20 papers in the last 5 years. Now, pick your top 3. The ones that you, not the ones that have been published in the best 3 journals, the top 3, the ones that you think you made an impact, and I'll read them. And the rest, I'm just going to ignore because it's just bean counting. That, I think, brings back a little bit of quality into quality control instead of just doing the simple thing. It's like,
rather than just churning out one paper after another and just
Right.
measuring by the pound.
Right.
And I mean, Adam and I have applauded efforts like that because it actually gets back to let's read the paper and let's actually understand what it is. And who cares what it is? You can almost blind yourself to what journal it's in, right? With all due respect to Nature. And I mean, Nature Springer has every range, top to bottom in terms, I don't mean bottom, but a range of selective or
sound
perhaps
science,
less.
from highly selective to sound science.
But, and if I can be just sort of dark for a second, and I just, because to put things in perspective, we're talking, you're talking about, an American university. I think in Western Europe you see a lot of movements to do that. And Mariette was talking about some different funding models that are, I would argue, progressive in terms of that. Certain parts of the world are going exactly in the opposite direction. So, for example, in China, you get a half-salary bonus if you publish in a journal with a certain impact factor. Depends on your field or what have you.
So you get a paper in Nature, you're going to
Nature,
get...
forget it. I think they buy you a palace. But I'm talking about, a sort of respectable...
Okay.
Yeah.
You get a paper in just a respectable journal, and you're going to get 6 months of salary. Is
Right.
that what you're saying?
And you can keep hitting that pinball, I don't know if that metaphor works anymore today, but you can keep hitting that, as many times, I'm sure there's some limit or what have you, but the point is, I like to think of myself as a fairly, I'm going to do what's right and sort of all the ethical person. I got to tell you, if I, was offered the opportunity and had figured out a way to do it, I might sort of, and even if I thought, well, I'm still doing the right thing, it's going to clearly do something. And every country is somewhere on that spectrum. And even some, for example, in the UK, and it's changed a bit. So this is being maybe a little bit unfair, but there are these sort of these exercise frameworks where you look at evaluation framework, where departments get more money or your university gets more money from the government if you have an average impact factor and a certain number of papers and this sort of thing. So I applaud all of the efforts that people are making to get away from that. I think we just have to sort of look at this globally and understand what's happening.
So I just want to, before we take some questions, I just wanted to switch it over a bit more to focus more on sort of like that next step from the journal to the rest of the world, like as stuff spreads out through the news, through magazines, through newspapers, online, and so on. Are we sort of like on the outside of this sort of dynamic? Do we have like nothing to do with it, or are we kind of are we part of the problem? We can get to the solution later, but are we part of the problem?
Yeah, we who?
Depends on which
We journalists.
We journalists, yeah. So
We'll
just
get
like the
confessions from
spectrum,
journalists first,
yeah.
and then the scientists can...
just like the
pass it.
spectrum of anything, yeah, sure. Many of us are clickbait chasers. Many of us are publishing the latest headline. Many of us are...
So we're going to look for that paper with the flashiest claim.
Yeah, it happens. I'd be lying if I said it didn't. How do we approach it? Those of us who have the privilege of, in the case of Scientific American, let me put that hat on as editor-in-chief there. One of the first things I did when I became editor-in-chief of Scientific American a half a dozen years ago was, instead of having the scientists write more in that received wisdom kind of way, which I was describing earlier, applied to education. But we used to have science. So one of the things I should have said earlier, in case people don't know, is about half, maybe more, of the feature articles in Scientific American are written by scientists. They're written in collaboration with our journalists so that they're accessible, but they're written by scientists about their work. And in the past, we used to let the scientists write in kind of a lecture style, as if everything was solved, and it would look over the past 3-4 years, and it kind of came out like, here's all the received wisdom. A thing that I tried to do, and I think is an example of, I like to think, I hope to think, a productive way to approach it is, tell us your story as if it's what I did last summer. What was your question? How did you try to explore it? When you made a mistake, what happened there? How did you get past it? Who did you talk to? And so I actually invited the researchers, and increasingly we do this at Scientific American, to speak from a first-person point of view about them and their teams, and embrace the fact that science is meandering, that we do make mistakes, that sometimes we see things in the data that because of confirmation bias or a mistake in the reagent or counterfeit technology that we bought that we didn't know, these things happen because it is a product of human endeavor. But because science is a process and an evidence-based one, eventually we write that over time, meaning we write in the sense of R-I-G-H-T rather than write it out. So I think that's one way we can contribute. Take the longer view. Don't just be slavish to the thing that maybe just happened, that's the sharp headline, but try to provide the context. And I think that's one place where, at least the journalism world that we participate in, we can benefit this process.
Ivan?
Yeah, I mean, Carl, you asked me about sort of, creating Retraction Watch. What made us want to do that? And I think one of the answers that I could also give is that we wanted to write about that process of science. I have to say, and so I was at Reuters Health. I was running Reuters Health at the time. Reuters, I'm sure you all know, is a large wire service, and Reuters survives, like most wire services do, on volume. And our clients were very clear about how much volume they wanted. And how do you write, and I could give you the numbers, but it's somewhat staggering and I don't want to scare people, but how do you create that many stories per week doing something other than writing about every study that comes out? Now, I'd like to think that and some of it was for a professional audience, maybe a medical audience that understood that. But I like to think we put the kind of context in that you would see at like Health News Review, which is a great site that tells you, gives ideas about how to cover medical studies in particular. The sort of the triad of coffee, chocolate, and red wine, right? I think that if no reporter ever wrote a story about chocolate, coffee, or red wine again, we'd all be better off. I like two of those things. The other one I don't actually drink, but that's okay. But the point is, I wouldn't say I had whiplash a little bit, but I had a little of cognitive dissonance, because here I was in my day job running a website that, not a website, but a wire service that had to pump out the volume. And we were reporting on single studies, dozens of them every day. And yet I was sort of trying to think a little bit more globally and slowing things down and thinking about the experience of science and what it all meant. Maybe that was useful, actually. Maybe it sort of connected some dots for me. But I think it would be great if more journalists did the sort of work that Mariette was describing, which is, and which I think this salon is very much about, which is about how science really works. We all need to get excited about what science is doing for us, but how do you really include at least some of that?
Well, I just want to touch on that before I let the scientists pass judgment on us journalists. The thing is that, I think when I became a fan of Retraction Watch, and then I started reading about some of these people that were featured there, which, I started to see more and more of these longer pieces about some of the more notorious characters. It was hard to look away, because in the most extreme cases where people would have to have 20, 30, what's the record? For one person having to retract?
183, actually.
183 papers from one scientist having to be retracted. And you start reading about these people, and they're just they're sociopaths. And fascinating. And you're like, how did this person go years and years and years lying to everyone around them? I mean, and we love reading about that. Is there a risk there that that we're going to swap the sort of naive idea of scientist as hero who is only about the truth, going to swap that for, scientists and sociopaths trying to get the next grant? I mean, is that a risk?
Absolutely it is. And it's something that, I wouldn't say we thought of on day one, but that hit us, sort of smacked us in the face quite early. And the way that we try and combat that, if you will, both in our own minds and our own work, but also in terms of the public. So, one thing that has happened, I don't know that it would surprise anyone to learn that a lot of what I would sort of frankly call anti-science forces, advocates, have seized upon what we do. We're very popular with them, not all of them, but with some of them, and so we're very conscious of that. One of the things that we've done to try and combat that is to create something called, this gets back to something Mary was talking about in terms of trying to correct the record and doing the right thing. We have a Doing the Right Thing award that we create actually with STAT. It's Adam and me and Adam in our column there at STAT. We handed out the first one just about a month ago. And the idea there is to reward people who do the right thing by correcting the record at some cost to themselves, right? Because, correcting the record is great, very important, but you actually may face consequences if you do that. And I think we've talked about what some of those consequences can be. And we call it it's Doing the Right Thing, so it's called the DIRT Award, which is almost the acronym for, because sometimes you have to get dirty to clean up the scientific record. We like to market stuff too. But I think that if you approach it and tell those stories as well, and we really try and tell those stories as well, I think you at least over time can tell the whole picture,
So before we turn to some questions, I want to hear from the scientists about how you feel the journalism world fits into the issues that we've been raising about the competition, the pressures, and so on. Is the way that the journalism is covering it kind of making things worse or better? I mean, what's your perspective?
The preferred answer of a scientist is, I never said that, as the journalist made it up. And sometimes that does happen, or at least there is some major difference between what comes out of my mouth and what comes in print.
More
right?
often what happens is the scientists would say, I know I said that, but I prefer that I didn't.
Yes,
so
there's that too.
We're always getting these,
course.
people demanding to see
Right.
our articles in advance because I just want to check my quotes because
Yeah.
maybe I said something I shouldn't
Right,
have. And I'm
right.
like,
No, there is that too.
You're on the
But
record.
I think that one of the things that is changing the equation, well, two of the things that are changing the equation is one, as you know, journalism is now in its own interesting situation. I have friends who are journalists, and it's not easy to maintain a job as a journalist. Often you're a freelancer. That means even more pressure, even less time to check stories, even more pressure to go for the sexy stuff and all that. So that's one side of the equation. The other side is more and more young scientists, especially beginning with PhD students and then postdocs and young investigators on tenure track, they start actually writing their own stuff. They write blogs. I write 2 blogs, so I communicate directly to the public. That's interesting because then I have journalists who come to me and want to talk about something that I published on my blog, not something that I published in Department of Literature. And so that I think adds an interesting dynamic. I don't know where it's going. At the moment, however, I kind of welcome it because I do think that that it's a good thing to add the voices directly of the scientists. Scientists should be more conscious about talking to the general public. After all, as you were saying, not only our education, but most of our money for research and so on and so forth does come directly or indirectly from taxpayers. And so it's just right that we spend some of the time talking back to those people and say, hey, here's what I do and why is it interesting.
so that's part of being a scientist.
That is part, I think, of being scientists, and now it has been, of course, historically this was a problem because your colleagues will look at you and say you're wasting your time. Either you're wasting your time or you're not a good enough scientist, and that's why you're doing that instead of another grant proposal. I think that's changing. Planck famously said that, Max Planck famously said that ideas in science get accepted one funeral at a time because the old people die. I think that's true also for other attitudes within science. That is, the old guard is retiring and then getting out of the way, and so the new people have grown up with social networks and Twitter and blog and things like that. And I think that actually is almost an unqualified good at the moment. We'll see how that evolves over the next decade. But.
Danny, I'll give you the last word before
Yeah,
we start.
I
getting
agree
questions.
completely. I think that, so I don't begin to understand the constraints that a journalist faces. I have 2 inches to describe something that took someone 6 years. And that when you have to go from the boring details that make it science and make it trustworthy and pick out ooh, this is the wow, right? We call it the gee whiz stuff. You lose something, and it can come out wrong. And I know that when I've worked with journalists, I ask to see it, to check the facts, not to check that I come off a certain way, but facts can change when you change the structure of the sentence. If it takes me 20 words to say something, because I'm trying to be really accurate and really precise and not let it get blown out of proportion, and you have to trim it down to 6, then it becomes a sentence that, you use the word prove. I use the word, I'll say, well, I have evidence that it's not this, and it's evidence, and it takes me
Yeah.
time
But you
with
proved it.
right,
You proved it.
and then that becomes
Exactly.
proved, and now the
I have a
people,
headline to write.
you have a headline to write, and now people think that scientists prove things, and that I think is difficult. I don't know what the answer is, I accept a very deep cultural shift, and I hope things like this festival will encourage it. But there was a time where you needed to know science to be considered an educated person. And now you need to know the humanities. I don't like Shakespeare, but I think that you shouldn't be able to avoid learning biology because you're an English major. I think that we have to go back to a time where even if you do use the word prove, people understand what that means in the context of science. They can read that and say, oh, okay, what that means, it's automatic that they will interpret that as we have a lot of evidence that supports this idea, so we're running with it. And if that was part of our citizenship almost, I think that would help a great deal. I don't know how to make it happen.
Okay, so can we, it's a little hard for me to see, but could we field some questions?
Oh, there is an audience.
Hey, look at that.
So I don't know if do we have a microphone to, oh, we do have a microphone to pass out. All right, so raise your hands high. So how about we start with that person? Okay.
How much of this problem in communicating about science might be due to the fact that you have some people, some philosophers who would argue that scientific truth is as relative a truth as is simply as good as any other form of truth. I'm talking about the relativist deconstructionists. I'd be interested in hearing what the panel would say.
Well, since I'm the resident philosopher on the planet,
Throw it to
I'll
you.
take that one, right?
Yeah, there you go.
Yeah, so there is an issue with that, but I really believe, I'm not usually an optimist, but I believe that that's done and over with pretty much. This was these so-called science wars. Mostly they happened during the 1990s. There was a small but vocal set of postmodernist philosophers and sociologists, it wasn't just philosophers, who started going around saying, well, science is socially constructed, which of course is true. We were saying earlier, several times, science is a social enterprise. It is socially constructed in a sense. In another sense, of course, that social construction is not independent of the outside world. It's very highly constrained by the outside world. The response to that sort of extreme version of postmodernism actually came both from scientists, Alan Sokal here at NYU, for instance, and especially by philosophers of science. The philosophers of science were very strong in responding to that sort of extreme criticism of science. And I think actually we're in a good place at the moment between the two disciplines because there is a good balance where the scientists themselves tend to realize that yes, there is in fact quite a bit more of the human side to doing science. There is mistakes, there is fraud, there is all sorts of stuff.
All right, do you have the microphone for someone else?
So my question is to do with a topic which was briefly touched upon, which is replicating research, and that there are no real incentives for that. Have any of you, do you have any ideas about how there might be incentives to replicate studies, perhaps work it into the system where, just like a lot of professors at universities are required to teach, maybe graduate students are required to replicate research before moving on to original stuff?
I'll address that. I want to qualify that there's no incentive to replicate. often, so all results are comparisons. You're always comparing what you got to something else. And in many cases, what you're comparing to is what the last guy got. So you're replicating it as one of your controls. So it does happen. What you suggest is a great idea. And one way of teaching and getting your students kind of up to whatever boundary you're pushing is to have them replicate what's been done. That's how you can learn a technique. That's how you can really understand what the person, your competitor, found. Do you agree with it? Don't you agree with it? And you can use that as a teaching tool. So there's ways of sneaking it in. You can't just publish a paper where you replicate what everybody else did. But often you can include the replication as that which you are building upon. So here's where we started. Yes, we agree. But now look at this. And so I think that it's not as clear cut as we have no incentive to replicate. I think it's you can use it.
Any other ideas about fixing the replication rule?
I mean, I think I'll try and make them sort of two quick, opposite sides of the same coin maybe. One is that I would argue, and it gets back to something Massimo was saying earlier, that I would actually argue that some people have made their careers, or starting to in this case. I think things are changing. Not so much in replicating, but actually failing to replicate. Now that creates its own sort of bias, because if you become known as the person who always goes out and fails to replicate, then you kind of show up to the saloon with a couple of guns or something, 6-shooters. But there can be a sort of incentive of its own to do that. And the other is probably talking out of the other side of my mouth when I was talking earlier about we have too many metrics. Well, if we're going to be stuck with metrics, well, we could make this into a metric. You could have something Adam and I, sort of at a very high level called for a bunch of years ago, a transparency index. Like, out of a given journal, out of a given maybe lab, out of a given sort of field, what is the likelihood that something actually holds up? And if you turn that into a positive, and if you say, well, the higher it is, the better, then maybe you'll have something that sticks. But again, those are not particularly well-formed ideas, to be honest.
I mean, what about, on the journalism side, what could we do to sort of let people know that one little crazy sounding paper in Science, we'll say,
Usually is.
May not be the last word. Turned out that was wrong. That bit article we wrote, no. How do we sort of build in that process of replication into the journalism about science?
Well, maybe I'm going to sound like a broken record at this point, because part of what we do when we choose what we cover is we celebrate things in effect, right? Because we've chosen that we've lovingly curated a story and presented it. I think one way we do that is we portray the lives of scientists. We portray what is it like in a lab. The Times used to have a piece that I loved a lot, which was about working life of scientists. I've had many researchers tell me that, you have no idea how long I spent writing this software program so I could do this piece of research on cosmology. It's all of that we should celebrate as well, not just the result that pops out. So yeah, that's one way we could contribute.
Question here.
So we're talking a little bit about the discussion section in experiments and how that's really just not the science of it, and yet it's the most interesting part. So I'm a philosophy student, and a lot of what we do when I'm in classes doing research is we look at the discussion section in science pieces. And so I'm not really reading the rest of the experiment, or I am, but briefly I'm looking at what their conclusion was and what they're discussing. So really, should we be taking a lot out of that and writing our own papers off of it, or should we just be looking at the experiment side?
Oh, wow. That's a great question. The discussion section is part of the science. It's the most educated mind at that point, the person who did the work and got those results. At that moment, that is the most educated guess, and it's often right. You develop experience, you develop, you learn as you go. So it's certainly part of the science, and the interpretation is very interesting, and putting it in context is very interesting. But I would say that you might be able to put a layer of depth into your understanding of how we got to that if you look at the results, if you look at the part that is just, here is what we got, and then the process that we go through. Okay, how many different ways could I have gotten this same thing? And then you go through, and then you go in the discussion and you say, well, I might have gotten it if A was true, but I could also gotten it if B was true. And that process of forcing yourself to not fall in love with one interpretation, the danger of falling in love with an idea. And we fall in love with our ideas. It's very creative. And I think that if you were to go and look at the difference between what's in the results section, where they say this is what happened, and how that gets turned into a discussion section, where there's the philosophical underpinnings of it, where you're thinking about necessity and sufficiency, and you're thinking about all those very basic intellectual processes that are behind it. I think that you might get something different and very interesting, comparing just the facts, ma'am, to here's how I interpret this, and here's what I think is important about it. I think that'd be an interesting way to look at it.
But there is an additional problem there, right? So there's a meta problem, if you will, which is scientific papers are, in a sense, pieces of fiction. Science
Some of them actually are fiction.
Well, some of them really are fiction, but all of them, to some extent, are in fact pieces of fiction in the sense that it really didn't happen like that. This is the structure of the paper is incredibly artificial. There's this introduction.
Like, I did this, and then I did this.
No, first of all,
and then I
no.
had
First
th-
of
then
all,
I had this great
you
insight.
don't even do that.
Right.
You write in third person. They did that.
Yeah.
We did that.
No, it
or
was
something like
passive
that.
voice.
Right, it's
No,
passive voice.
not
yeah.
This was
anymore.
done.
So it's like that's changing, fortunately.
changing.
But it's like it's like you're supposed to be distancing yourself as much as possible, right? And so this is this very structured thing: the introduction, the materials and methods, the results, and the conclusion and the discussion. And they're supposed to have these really different functions, as if you're sort of pretending that when you write the introduction, you really don't know at that point how things are going to turn out. But of course, you wrote the introduction after you've done the experiments, after you've done the data analysis. In fact, typically the way I don't know how other people do it, but the way I taught my students to write the papers was never to start with the introduction. You always start with the results, because you want to have the results in good shape, and the diagrams, the tables, and all that. After you've done that, then you sort of write you write the rest of the actual narrative that goes with the results. Then maybe you're going back to a little bit of introduction, discussion, then you go back and forth until everything fits together. So it's a work of fiction. Everything is put in a way that it's not the way it actually went. But I don't mean a work of fiction in the way that you are, obviously, that problematic one. But it does give the impression, even to the scientists themselves, that there is a lot more objectivity, a lot more rigor, a lot more sort of, well, it had to be that way, than there really is. Science is much more fun than that. But it's much more unpredictable. Imagine if you were actually writing a scientific paper the way in which you write a novel or a little short story. It's like, oh, so we started out this way. We were having coffee that morning with my graduate student, and he said, damn, we don't understand this. That would be much more true to the way things actually happen. I'm not suggesting that's practical, but you need to keep it in mind that when you read a scientific paper, there is a lot of rearranging of stuff going on.
And when I interview somebody for an article, I'm always I just kind of like set the paper aside and be like, okay, come on, how did this really happen?
Right, exactly.
And you get a bizarre story that you never would have guessed from reading the paper. Much more interesting one.
Yes.
I'd just like to thank everybody for attending today. So thank you all for coming.